So hey guys, welcome to our tutorial. So in today's tutorial, we are going to look at the application of KVL and KCL. So in this circuit diagram that we have been given, we need to come up with a value of I delta and VO. So now, this is I delta and this is VO. So these are the two things that we have been asked to calculate. So in this case, the application of KVL and KCL. So to start with, KVL, or in other words, Kirchhoff's voltage law. It states that the summation of the voltage across a loop is equal to 0. So the summation of the voltage across a loop is equal to 0. So what is a loop? So when we talk of a loop, we are talking about a closed path in the circuit. So any closed path in a circuit. So take for instance, this is a loop, this is a loop, and this is a loop. So in this circuit diagram, these are the loops. These are the loops. So a closed path in the circuit is what we call a loop. So when we talk of KVL, we are simply saying the voltage across a loop must add up to what? To 0. So meaning that if I add the voltages in this loop, so take for instance, if I name this as loop 1, loop 2, okay, L1, L2, so L meaning loop, then this L3. So the voltage across this loop must be equal to 0, across this loop must be equal to 0, as well as across this loop. So that's what it means. So meaning if I was to add 50, 20 sigma, the voltage across the 18 ohms resistor, I must get 0. So same as this loop. Yeah. So now when it comes to the Kirchhoff's current rule, so when it comes to the Kirchhoff's current rule, we say the current entering a node, must be equal to the current leaving the node. So take for instance, so we said in the previous video that a node is simply a point of interconnection across the branches. So the point of interconnection of the branches. So now when we talk of the branches, we are talking about the circuit element. So take for instance, we have this point, then there comes a branch, there comes a branch, and there comes a branch. So the current entering this node, we are saying it must be equal to the current leaving this this node. So this is the node, this is N. So I have I1, I have I2, I have I3. So in other words, we are saying this I1 must be equal to I2 plus I3. So this is because I2 and I3, they are leaving the node. At the same time, I1 is entering the node. So this is what it means by Kirchhoff's current loop. So now let's go direct into the question. So we are going to apply KVL and KCL. So let us start with the first loop. So we are going to name this as the first loop. So this is our first loop, second loop, third loop. So to start with, I I'm going to name this, the voltage across the 18 ohm resistor, as V1. I'll name this V1. So this one is already named, it is VO. So I will first start with Kirchhoff's voltage law. I'm going to start with Kirchhoff's voltage law. So now, with Kirchhoff's voltage law, we are saying the voltage across the loop must add up to what? To 0. So I'm going to start with the 50 volts, which is my battery. So to start with, so I'm considering this path, so as my L1. So in loop 1, what we are saying is we have so negative 50. So this is negative 50. So plus we have negative 20 delta, 20 sigma. So we get the sign that comes first. So it will be minus 20 I sigma, plus, so this is positive, negative. So it will be plus V1. So mind you, we are adding the voltages, plus V1. So I have added everything in this loop. So everything now must be equal to what? To 0. So according to Kirchhoff's voltage law. So now I think I can make changes. Where necessary, because at the end I want to have like terms, or yeah, I want to have like terms. So where there is V1, or I want everything to be in terms of current, so I don't want to have mixed variables. So I'm going to, replace V1, because this V1, I'm going to replace it in terms of current. So I have the 18 ohms, and I know the current that is going through the 18 ohms. So the current that is going through the 18 ohms is I delta. So in other words, what we are saying, according to Ohm's law, we know that voltage is equal to current times R. Which is resistance. So in other words, this V1 is equal to 18, that is my resistance, times I delta. So I am going to replace now in this equation. So replacing, I get minus 50 minus 20 I sigma, plus I have 18 I delta equal to 0. So I have 18 I delta minus 20 I sigma equals 50. So this is my equation 1. So we can now move to the next group. Which is group 2. So we now go to this group. So in this group, we are moving. So we are moving. This is the group. So what we have in this group, we have the 18 ohms, we have the 5 I sigma, and we have the 40 ohms. So it's now a matter of computing all these. So we are saying what we have is, so now we are moving from this side, going up. So you get the first sign. Which is negative. So the voltage across this, according to KVL, the voltage across this, I have negative V1, that is the voltage across the 18 ohms, plus the first sign is positive, so I have 5 I sigma, plus I have the voltage across the 40 is VO equals 0. But what we must know is we must know that V1 is 18 delta. So what we don't know is VO. So we are doing this because we want to leave everything in terms of current. So my VO is simply equal to, I know that the current entering this junction is I sigma. So according to Ohm's law, we say voltage is equal to current times what? Resistance. Current times what? Resistance. So I am going to replace the resistance here is 40 and the current is what? I sigma. The current is I sigma. So my voltage is equal to 40 I sigma. That is my voltage. So I am going to replace. So where there is V1, I am replacing with 18 I delta. I already solved this. I solved this already. So this is 18 I delta. Plus I have 5 I sigma. Plus I have this as 40 I sigma equals 0. So this plus this, I am getting 45. So I am getting 45 I sigma equals 0. So I will get this as my equation 2. So I now have two equations. So I now have what? Two equations. So two equations in terms of I sigma and I delta. So I can solve them simultaneously. So let me just write these currents somewhere here. I don't want to lab my circuit diagram. So I have 18 I delta minus 20 I sigma equals 50. Then secondary, I have 18 I delta plus 45 I sigma. This is equal to 0 again. So it's possible to solve these two simultaneously. So we can solve them simultaneously. And by solving them simultaneously, so okay, let me just lab this part. So solving this simultaneously, what we have is we are adding in. So we are adding 18 plus negative 18, it's 0. Then negative 20 plus 45, we get, so we are getting 25. So we are getting 25 I sigma equal to, what is 50 plus 0? So we just get 50, just like that. So over 25. So I sigma is equal to, I sigma is equal to 2 amps. So I sigma is equal to 2 amps. But we have one equation because what we are looking for is I delta. So we have an equation connecting I delta and I sigma. And this equation can get one from these two. So I'm getting this simple equation. I know that I sigma plus 45 I delta this is equal to 0. So I am just replacing I sigma with 2. This is equal to 0. So I have 18 I delta equals negative 45 when it crosses this side, with negative 45 times 2 in brackets. So we can divide throughout by negative 18. We can divide throughout by negative 18. So we have I delta as, so my I delta is equal to, so positive and the positive will go. So what is 2 into 2? It is 1. What is 2 into 18? It is 9. The 9 into 45, what I'm getting is 5 amps. So in other words, we are done with the I delta. The I delta is equal to 5. 5 what? It is equal to 5 amps. So it is equal to 5 amps. So what else? I'm sure we have been asked to come up with a VO. So what will be the value of VO? So the value of VO is simple. We now know the current that is flowing through this junction. And that current is already assigned as what? As sigma. So it is sigma. So this sigma is the current that is going through the 40 ohms resistor. But according to KV, according to Ohm's law, you know that voltage is equal to current times resistance. Voltage is equal to current times resistance. So VO is equal to, the resistance is 40. So we have 40. So this is 40 times I sigma is simply 2 amps. So we get this as, this times this is simply 80. So we have got 80 volts there. So these are the answers to the problem. So that is VO is equal to 80 volts and I delta is equal to 5 amps. So these are the answers to our problem. So remember to subscribe to our YouTube channel, comment and like the videos. So thank you so much. We'll meet in the next story.